विद्यार्थी मित्रो, गेल्या पिरियडमध्ये आपण फोर्सचा स्टडी केलेला आहे. त्याच्यामध्ये सेंट्रिपिटल फोर्सचा स्टडी केलेला आहे. आता आपल्याला ग्रॅव्हिटेशनमधलं दुसरं जे काय आर्टिकल आहे केप्लर्स लॉचा स्टडी करायचा आहे. केप्लर्स लॉ अबाउट द प्लॅनेटरी मोशन. इन एन्शियंट टाइम the astronomer suggested that किंवा astronomer study about the planets, they study about the motion and position of the planet with the help of their naked eye. But after the 16th century, when Galileo discovered the telescope, with the help of the telescope, the scientists study about the motion and the position of the planets with the help of the telescope, and lot of information is available during this period. And with the help of this information, Kepler studied about the position and motion of the planetary motion, and he suggested the three laws, and these laws are known as the Kepler's law. Before the Kepler's law, we discuss about the ellipse. The shape of the ellipse is like this. If we cut the cone in inclined plane, at this time that shape is known as the ellipse. Ellipse have the two axes. One is the major axis and second is the minor axis. Suppose AB is the major axis and CD is the minor axis. Then that ellipse have the two focus. That means suppose this is the focus P and this is the focus Q. When the Kepler study about the motion and position of the planet, focus on the points motion and position of the planet. Position of the planets. Kepler study about the motion and position of the planet with the help of the telescope which is discovered by the Galileo. At this time, he considered the ellipse, and ellipse have the two foci. One, suppose this is the position of the first focus and this is the second. Before this, he considered the position of the any planet. Suppose this is the position of the any planet. The position of that planet is AM position. At this time, he considered that the sum of the position of the any planet to the focus. That means he take the sum of the distance between the P and M, PM plus EMQ. He take the any point on the ellipse and join this point to the both focus. Then we take the sum of the PM and QM. Again he take the position of the same planet at any position. Suppose this is the position of the planet in other time. Again he joining the point, focus point P and N, and then N and Q, and take the addition of the PN plus QN. He found that when we take the position of the planet in the circumference of the ellipse and join that point to the focus, the sum of these distances are always equal. That means this is the first position of the planet M, join the focus point PM and QM and take the addition of these two, PM plus MQ, it is always equal to the position of that same planet in other points. Take the distance this PN plus QN, both of them are equal. That means this is about the information of the position of the planet to the focus. And then we discuss about the first law of the planetary motion. The orbit of an planet is an ellipse with the sun at one of the foci. That means first we discuss about what is the motion of the any planet. Suppose this is the ellipse. Any planet is moving along the circumference of the ellipse. The shape of the ellipse is like the X. This is the ellipse. This is the position of this is the major axis. This is the any one of the foci. Suppose this is F1 and this is F2, and sun is present at any one of the foci. Suppose sun is present at the F2. This is the position of the sun. The orbit of an planet is an ellipse with sun at one of the foci. ज्यावेळी सूर्य या इलिप्सच्या कोणत्या तरी एखाद्या फोकसवर असेल त्यावेळी त्याच्या भोवताली फिरणारा जो काही प्लॅनेट आहे तो प्लॅनेट इलिप्टिकल ऑर्बिटमध्ये फिरतो, किंवा एखादा प्लॅनेट इलिप्टिकल ऑर्बिटमध्ये फिरत असताना त्या इलिप्सचा जो काही मेजर ॲक्सिस आहे त्या मेजर ॲक्सिसवर असणारा जो काही फोकस आहे त्या फोकसवर सनची पोझिशन असते. म्हणून फर्स्ट लॉ इज दॅट the orbit of the planet is an ellipse with sun at one of the foci. म्हणजे केप्लरने पहिला लॉ सांगितलाय की ज्या वेळेस एखादा प्लॅनेट इलिप्टिकल ऑर्बिटमध्ये फिरत असतो त्यावेळी सूर्य हा त्या इलिप्टिकल ऑर्बिटच्या कोणत्या तरी एखाद्या फोकसवर असतो. हे केप्लरने विथ द हेल्प ऑफ द ऑब्झर्वेशन he considered that the position of the sun at one of the foci of the elliptical orbit. This is the first law. The orbit of an planet is an ellipse with sun at one of the foci. Second is that when we consider the elliptical orbit of the any planet, suppose this is the position of the earth. A is the initial position of the earth, and when earth is revolving around the sun in the form of the elliptical orbit, after some time the earth reaches to the point B. At the same time, also you can consider this is the position of the sun. Sun is at one of the foci. Suppose this is the position of the sun, and when we line joining the position of the sun and earth, the position of the sun and earth, the initial position of the earth and sun is joined, this sweeps the area to the B. ज्यावेळेस A पोझिशन पासून B पोझिशन पर्यंत अर्थ रिव्हॉल्व होईल त्यावेळी जर आपण लाईन जॉईनिंग द पोझिशन ऑफ द सन अँड अर्थ जर अशी रोटेट केली B पॉईंट पर्यंत तर त्याला म्हणायचं स्वीप एरिया असं म्हणायचं. याला म्हणायचं स्वीप एरिया बाय दी अर्थ अँड द सन. लाईन जॉईनिंग द सन अँड अर्थ sweeps the area that is nothing but the sector SAB. At the same, again, after a few minutes, suppose this is the position of the earth at point C. Earth reaches to the point C after some time, and when we consider from the point C, suppose this is equal to 1 hour. Earth reaches from A point to B point within 1 hour. In next 1 hour, when we consider the position of the earth at C and it covers a distance up to the point D, at this time the line segment joining the sun and earth sweeps the area that is nothing but the SCD. Suppose this is the area, any area, suppose this is the area A1, this is the area A2. That means from the point C to D, sun covers a distance within a 1 hour. Again we consider the earth reaches to the point E. After some time, earth reaches to the point E, and again you can consider from E to F, this distance covered within a 1 hour. At this time, the line segment joining the sun and earth sweeps the area sector SEF. And when we find the area swept by the line segment joining the sun and the earth, suppose this is A1. We determine the value of the A1. Again we determine the value of A2. Again we determine the value of A3. These values are equal. And from this, he suggested that the line segment joining the sun and earth sweeps the equal area in equal interval of time. प्रत्येक वेळेस एका तासामध्ये त्याने जो काही स्वीप केलेला एरिया आहे हा स्वीप केलेला एरिया आहे प्रत्येक तासामध्ये अर्थ आणि सनला जोडणारी जी काही लाईन आहे या लाईनने स्वीप केलेला जो काही एरिया आहे तो प्रत्येक इक्वल इंटरवल ऑफ टाइम मध्ये सेम आहे हे केप्लरने सांगितलं. The line joining the sun and the earth sweeps the equal area in equal interval of time. This is the second law. the line segment joining the sun and earth or sun and planet sweeps the equal area in equal interval of time. This is the second law. Third law is that when the earth is revolving around the sun or any other planet is revolving around the sun, at this time the cube of the time interval of the planet revolving around the earth is directly proportional to the square of distance between them. The square of the period of, suppose initial position of the earth is B and earth is start revolving from point B and reaches to its original position, that is nothing but the total required time or total interval time of the earth. The t square, that means total interval of time revolving around the sun by the earth, is directly proportional to the directly proportional to the cube of the cube, directly proportional to the radius of that ellipse. That is nothing but the Kepler's third law. Mean distance of a planet from the sun. When we take the mean distance, suppose this is the ellipse and at one of the foci, this is the position of the sun or this is the position of the sun, and any planet is revolving around that sun in elliptical orbit, the type square of the time period of the revolution of the planet around the sun is directly proportional to the cube of the mean distance between the sun and the earth. When we take the average of this is the mean distance between the sun and the earth. That is nothing but the third law. Third law, with the help of this equation, you can explain the third law. T is the time period of the planet. D is the mean distance between the sun and the planet. That means the relations, he represents the relationship between the time period of the planet and the mean distance between the sun and the planet. The third law is that square of the time period of the revolution of the planet around the sun is directly proportional to the cube of the mean distance between the planet and sun. This is the third law. With the help of this statement, you can explain the third law. The line segment joining the sun and the earth sweeps the equal area and equal interval of time. That means A1 is equal to A2 plus A3. म्हणजे प्रत्येक समान कालावधीमध्ये त्याने जे काय कव्हर केलेला एरिया आहे तो इक्वल आहे. आणि फर्स्ट इज द ऑर्बिट ऑफ द एनी प्लॅनेट इज एन इलिप्स, but at this time sun at one of the foci. These are the three Kepler's law about the planetary motion. To stop here.